Hello and welcome to this learning video. In this learning video, we are going to take some more problems on mathematical expectation, variance and standard deviation. Okay, so let us see the problems. So first of all, we'll take a problem on discrete random variable, then continuous, and then a problem where nothing is given to us, like the problem, like the example is of discrete or continuous. So at that time we just do as directed. Okay, so this is the problem. Now as you can see, this problem says find the mathematical expectation of x whose probability function is this. Okay, so as you can see, the value of x is given as 1 2 3 4 and 5. So this is a problem of discrete random variable because the range is not given to us. This x can take values like 1 2 3 4 5. So this is a problem of discrete random variable. So you can write for, and it is already written here, discrete random variable. If it is not written, then you can identify like this. Okay, so for discrete random variable, we know that what we know that the mathematical expectation, we know that the mathematical expectation is, what is it? It is denoted by expectation of x, and for the discrete random variable it is written like summation x into f of x. Okay, here summation runs from 1 to 5. Okay, that is expectation of x is equal to summation, you can write here only x is equal to 1 to 5 because here you don't write, according to the problem we'll write. Okay, summation x f of x. So put x is equal to 1. So the moment you put x is equal to 1, it should be 1 into f of x. So f of 1 is 1 by 50 plus 2 into 2 by 15 plus 3 into 3 by 15 plus 4 into 4 by 15 plus 5 into 5 by 15. Okay, no further terms required. So this is like 1 plus 4 plus 9 plus 16 plus 25 upon 15. So sum of this would be 25 plus 25, 50, 54, 55. So this is 55 by 15. So the moment you divide 55 by 15, you'll be getting, this is 5 3s are 5 11s are, so 3 11 divided by 3, so this is 3.6667. so this is nothing but the mathematical expectation for the given problem. Okay, so sometimes some simple question may be there, and sometimes and such type of problems are there in the examinations, like competitive examinations. So let me take one more problem. You can see the problem over here. Okay, now let me take one more problem so I can write a question. Okay, so let me write down next problem. The problem is, let x be the random variable, let x be the random variable with density function f of x is equal to 3x square and 0, 3x square for the range 0 to 1 and 0 otherwise. Okay, find expectation of x and variance of x. Okay, so this is the problem we have, and just look at this problem. This problem says let x be the random variable with a density function. The moment you find such type of terminologies in the problem, so you can conclude that this problem is of continuous random variable. If you can't identify with the help of this, identify with the help of this range. So whenever there is a range is given to you like this, sometimes range will be given to you like this. Okay, so in such cases you can identify this example to be a problem of continuous random variable. Okay, now what we have to find out, we have to find out expectation, and expectation, that is mean, and variance. Okay, that is sigma square. So as you know that this is a problem of continuous random variable, so let us start with solution, and you can write for continuous random variable expectation of x is nothing but, what is it, integration from minus infinity to infinity x into f of x dx. But as you can see here the range is given like 0 to 1, so you can break this interval like minus infinity to 0, then 0 to 1, then 1 to infinity, or you can simply write expectation of x is equal to, if you want you can write it like minus infinity to 0 x into f of x dx plus integration 0 to 1 x into f of x dx, plus you can write integration from 1 to infinity f of x dx, x into f of x dx. So from minus infinity to 0, minus infinity to 0 comes under this otherwise, so this is 0, and this 1 to infinity is also comes under this otherwise, so functional value is 0. So these two things, first and the last one, contribute to 0, so we remain with integration 0 to 1 x into f of x dx. Simple. So this is integration 0 to 1 x into, what is f of x in the range 0 to 1, we have 3x square dx. So this is nothing but 3 outside, integration of x cube is x to the power 4 by 4, limit 0 to 1, so this comes out to be 3 by 4. Right, now after this expectation of x, let us find out expectation of x square. Therefore expectation of x square is integration, I am writing directly now, integration 0 to 1 x square into f of x dx. Okay, so this is nothing but, what is this, integration 0 to 1 x square into 3x square dx. So this is 3 integration 0 to 1 x square into x square, x to the power 4, so integration of x to the power 4 is x to the power 5 by 5, 0 to 1, so answer is 3 by 5. Okay, so this is expectation of x square, this is expectation of x. Okay, you can easily find out the variance. We know that variance of x is nothing but expectation of x square minus expectation of x whole square. That is the definition. So what is this expectation of x square? Just we have found out, that's 3 by 5 minus expectation of x 3 by 4 whole square. So this comes out to be 3 by 5 minus 9 by 16. So this is 48 minus 45. So that is 3 by 80. So what we have found out at last, you can just, that is what you have to find out, expectation and variance. So at last you can write, therefore expectation of x is equal to 3 by 4 and variance of x is equal to 3 by 80. This completes the solution of this problem. Okay, so I hope these problems are clear to you, and such type of problem will be very helpful in competitive examinations. Okay, you just need to remember what is expectation for discrete random variable and what is expectation for continuous random variable. Now let me take one more problem. So I think the next problem I can take in the next video. So I hope this is clear to you. So thank you for watching this learning video and have a good day. Thank you.